Hey, hello, welcome to the show. It's me, John Park. It's time for John Park's Workshop. Thank you all so much for tuning in. I've got a fun show for you here today, and I want to thank you for stopping by over in our various chats. We got people over in our YouTube chat. Hello to Robert Cochran, David Odessa, Beatagraf Avdal Hagen, Quinman16, Johnny Bergdahl. Hello, thanks for popping in over there. If you're somewhere else like Facebook, say, or LinkedIn Learning, or Twitch TV, and you're wondering, hey, where's the chat? Then I would recommend you head over here to our Discord. You can get there by going to adafru.it/Discord. Look for that live broadcast chat channel right there. That's where people are hanging out. Hey there, Paul Cutler stopping by. Let's see, who else we got? C. Grover, hello. John Nodge, Johnny Bergdahl is there as well. Thin Man, hello. Yes, that's the people that are here. Hi. So yeah, apologies, no show last night. Things got impossible for Phil and Lamore. They had to take care of kid without babysitter and things like that, so no show, but they did do some pre-records of some things that will be airing later, so just keep an eye out on the Adafruit blog and YouTube channel and Discord, and you'll see as things show up. Let's see, Robert Cochran said, JP, I bought some QT Py ESP-32 boards. Excellent. I love those. I'm using those for this project. In fact, we'll take a look at one today. Do I have one here? Yeah, do I? No. Okay, yeah, I'll be using them in this project. Right now I've got them on a feather for some convenience, but love those little QT Pys. Let's see, what else? We've got a coupon code for you. We've got a recap of the Tuesday product pick of the week show. I've got a CircuitPython Parsec for you, a tooltip, gear report, amalgam. Sometimes they're the same thing. And we'll be taking a look at the juggling project with ESP-32, including a little bit of CAD and Rhino and Grasshopper to take a look at the latest version. And we've got, let's see, other people popping by over in the chat. Hi there, Mario from Argentina, who just popped up. Thank you. Username Ortega Computacion. I maybe got that somewhat close. So let's do it. First of all, I've got this coupon code. If you want to head over to the Adafruit shop and save some money, Ribbons is your coupon code for the day. That means buy some stuff, and then in the shopping cart on the way out, look for the coupon code slot. Type in Ribbons right there. That'll get you 10% off on things that we can send you. That doesn't work for software, or gift certificates, or subscriptions, but if it's a thing that goes in a bag or a box or a envelope and we send it through the post, then you'll get 10% off with the coupon code Ribbons today. If you have a look over here at the Adafruit shop, here's why I called it Ribbons, because look at these. These are neat. These are a new product that just came out. If we go to New Products, View All, we've got a couple of different sizes of these ultra flexible LED ribbon strips, 30 millimeters wide, 1 meter long. These take from 20 to 24 volt DC. I think I'm going to pick up one of them because they look really neat for lighting projects. They're flexible, and they are not a neopixel or not addressable. It's just light it up or not, and you can slice off sections of it as well. This uses little cob chip-on-board LEDs, lots and lots of them. There's 1,600 of them on there. And yeah, you can provide 20 to 24 volts to those to get those nice and bright. If you want to pick up that's new. That's the coupon code that will work on that and pretty much everything else, ribbons. So head on over to the Adafruit shop, get some stuff. It's how we keep the lights on around here. And you can save yourself a little money in the process. Also, I like to mention, if you head to the shop and wonder how much stuff to buy and you're teetering around one of these breakpoints, if you type in free, adafruit.com/free, we do have some enticements here. If you spend $99 or more, you can get this free PCB coaster with the Adafruit logo on it. If you spend $149 or more, you'll get the coaster as well as a KB2040 microcontroller. Excellent little microcontroller, particularly suited for drop-in keyboard and macro pad projects, but also great for all sorts of USB, HID, USB, MIDI, those kinds of projects. It really shines. And if you spend $199 or more, you'll get the coaster and the KB2040 as well as free UPS ground shipping in the continental United States. So check those out. Those are some enticements for ganging up a bunch of your stuff for your order, as well as still getting your coupon code 10% off ribbons today. And that's good until midnight tonight, East Coast time in the United States. Let's see. Oh, thank you very much. Ortega Computacion. Oh, now I've screwed it up. Computacion says, you sure you don't have some Spanish blood running somewhere? Italian. I'm half Italian, if that counts. Probably doesn't count. Okay, so what else? Let's take a look at this. This is what I do on Tuesdays. That is my product pick of the week show. I pick a thing, I show it to you, I give you a deep, deep discount. Thanks to the help of the new products team, we're able to stash a bunch before the show, usually 100, so we have some on hand, and give you a deep discount, in this case 50% off. Here's a little recap. Check this out. The Pi Stemma QT Breakout. This is a great way to add a nice, easy plug-and-play Stemma QT/Quick port for I2C on your Raspberry Pi single board computer or other compatibles. And you'll just line up these first 6 pins right here and press those down, and it is connected. And then you can plug in your little I2C cable, add your gizmo there. Plugged into those little 6 pins there. And then I have that running over to a Seesaw I2C Stemma QT Neo slider, which has NeoPixels that it's writing out to, the Raspberry Pi is writing out to, and then the analog pot slider that we're reading. Right there, that's the product pick of the week this week. It is the Pi Stemma QT Breakout for Raspberry Pi and compatible single board computers. Okay, next up, I've got a CircuitPython Parsec. Take a look. CircuitPython Parsec. Okay, for the CircuitPython Parsec today, I wanted to talk about the very simple switch to input command that we can use when setting up GPIO pins inside of CircuitPython. So what you see here is I've got a QT Py RP2040. I have a switch plugged into it, a little button over here, and I have a big 10 millimeter LED. Now, when I set up this button as a input, as a digital input, the traditional, typical way to do this is to set a direction. Is it a input or is it an output? These are general purpose. They can be input, output. So I'm picking pin A1 and I'm saying button direction is digital IO dot direction dot input. And that's based on having imported this digital IO library. Then I also have to set the pull up or pull down resistor state? Does this pin float, does this pin tie to ground, or does this pin tie high so that we know when we press the button which way it's going? So in this case, it's a pull up. So that's a separate command here. So we've got these two commands that'll set up the button. Now, a really nice convenience that we have inside of CircuitPython is to do it in one line. Wow, that's twice as efficient right there. Button is dot switch to input pull equals digital I/O pull up. So a single line takes care of both telling this I/O pin to be an input as well as the direction of that pull. Now when I press this button, we can see it's going to light up the LED. If I save this code with that switch to input, it works just the same either way, but you get it done in one line. And that is how you can use switch to input on your GPIO pins inside of CircuitPython. And that's your CircuitPython Parsec. CircuitPython Parsec. All right, yeah, I was just checking in the chat and someone had asked about the Ask an Engineer and Show and Tell. So yesterday there was Show and Tell. You can go check that out in the archive on YouTube. You'll see the Show and Tell. It was hosted by Noe and Pedro, and you can go take a look at that. It was Ask an Engineer that did not happen last night. So you can always check the YouTube, by the way. If you head to Adafruit's YouTube page, there's a live header category, and you can see all the live shows there. John Nodge says, pass-through headers are nifty. Yeah, I've still got one right here somewhere. Where did you go? I thought I had one right here. I've moved it. But yes, those little pass-through headers for the Raspberry Pi are pretty cool. Where did I put that? It's also small, so you might be like me and lose it if you have too much stuff on your desk. Okay, so next up, let's take a look at my little tool tip here. So these are really cool. I'm going to head over to the workbench here, and I've had these for a number of years. First off, the sort of tooltip followed by the gear report. So tooltip, this is one of these nice little oiling pens for light machine oil, sewing machine oil. Since I've been working on refurbishing this typewriter, I got this out. This has a nice little, very thin needle applicator that you can use to place oil very precisely instead of blobbing it all over the place, which in a thing like a typewriter is kind of important to keep it away from some stuff and get your oil on other things. So you can pick up these little pen oilers. There's different types. They're usually refillable. However, while I think this one may have come with a small cap on top, I didn't trust it. I didn't have a disaster with it, but I do worry about carrying this in a tool bag. I've got a little canvas tool bag that I carry around working on certain types of things. And so I placed it inside of one of these little clear plastic vaults. I forget what they call it. I'll show you in a second what the people I bought it from call it. But these they come in different sizes. These are what's also known as soda bottle preforms. And it's kind of a fun thing to go look up online how this works, but this is the injection molded plastic thing that becomes a 2-liter soda bottle through heating and pressure. So these are made, and then the factory, when it's time to turn this into a soda bottle, has a form, a metal die that's been created, and a little nozzle goes on here. This has been heated up, air is forced in, and bloop, it blows up into a 2-liter bottle. 2-liter bottle is fairly thin plastic. This is fairly thick because it's what gets expanded out into that large size. So these things are pretty darn strong. They're, I think, PTFE plastic, really, really thick and strong. You can get different sizes, shapes, colors of these. They are fairly inexpensive because it's just a part of a process that already exists that's been replicated about 1 million times a second around the world. This one has a nice little watertight cap on it. Not all of them will, depends. But for the most part, if you're getting them from a supplier who's making them for the soda industry, they're going to have a waterproof cap on there as well. And they do come with a tamper-resistant ring on them usually that has not been snapped off like I have in this case. So first time you use this, you can screw that all the way down and that little ring will end up below a lip, which means when someone opens it, you can tell that that seal's been broken. These are used for all sorts of things. One thing I was reading about that they're used for is medication in hazardous environments, the military, in EMT, where a glass vial needs to be kept safe. You can put it in this, you can still read it, you can still check barcodes and dates and things on them. But these are, so that's the gear report, is to say, hey, go check out, look for a source of some of these little preforms, because they're really nifty little vaults for holding your stuff. You can throw batteries in those, you can put small flashlights, earbuds, who knows what gear. Can be survival type of gear, doesn't have to be. This is a case where this is, I wouldn't consider my little oiler here survival gear, it's just something I want in my toolbox. You can also put little bits of foam. If you've got little squishy foam, you can place those in the ends to keep things from rattling around if you want. So that is my my tool tip there, little preforms, and I'll show you the one I got, that orange one there, and I think actually both those white ones, those all come from this place, CountyCom. Let me go to a web browser here. Right here, clear tube vaults is what they call them, and they are $3.25 for these. And they also have these orange cap packs, I guess, if you have a need to refill them with that little tamper-resistant ring in place. So that's countycom.com. I'm not paid to do any kind of advertising for them. I just like them. They make neat gear. They source neat gear. This is something that they had for a contract for the government to do some little storage tubes. They are, in this case, and that this won't always be the case if these are made for specifically just to sell as this, they may not be food safe, but if they were originally designed to be soda bottles, they're going to be food. These ones say food and pharmaceutical grade, crush resistant, PET, sorry, not PTFE, PET, polyethylene tetraphthalate. It comes with an airtight, liquid tight, tamper evident cap, and they're dishwasher safe. So you can get these. Search for them, you find them all over the place, but those are the ones that I have right there are from CountyCom. Good for small tools, lock picks, things like that. All right, so that's my gear report and tool report. Todd over in the chat, hey Todd, just posted a cool video of showing these in action. So go take a look at that soda bottle manufacturing video. That'll show you how those are heated and inflated up into full 2-liter bottle size. Thanks for that, Todd. Okay, so next up, nubs. I want to talk about nubs. I want to talk about nubs because I want to talk about these juggling ball, 3D printed juggling ball halves that I've been working on. And I want to show you how they're coming together. So I'm actually going to switch to move some stuff out of the way. I'm going to switch to this view right here of my Rhino session. So in 3D, I have the two halves of this, which I designed parametrically. So and I've shown this before on the show. So I have a little node network here, a little directed acyclic graph node network that allows me to, if we go to the very beginning, just worry about things like user input and change the ball diameter, inner shell offset for how thick I want it to be, and a couple of toggles if I want to see text show up on these or not. The rest of this is just a network of geometry operations that creates the ball of the size we want, slices it with this very particular type of projected curve to make the two halves of a tennis ball style sphere, which prints really nicely. I've shown this before. These print nicely because we don't have weird like resolution dependent tops and bottoms and supports necessary. So it's nice geometry to print. And on, I think it was Mouse's suggestion a couple of weeks ago, I added some, I showed on this one, I added some grooves so that we can put rubber bands around them to hold them together. However, Todd Bot, who just showed the plastic bottles there, suggested that I take a look at a trick that he used on these little Blink 1 smart LEDs that he makes, which has a little snap fit plastic. If I can pull this off and then show it to you without breaking anything. There's a little snap fit plastic shell. All right, I'm not going to try to get off. But you can see here this little U-shaped thing. It's suspiciously similar to my tennis ball, which might have given him the idea. That has a slightly tapered shape that snaps over with a snap fit onto the aluminum. So he suggested I look at that, and what I realized is, yes, since this is a slightly flexible form, if I add some protrusions, little nubs, which you can see here in Rhino as this little green semicircles there in this cutaway, and a little receiving hole for that, it will act like a plastic backpack buckle snap fit type of thing. And if you make that just the right size, it will snap click in but not be very easy to dislodge. So if I pull a little cross section here, you can see we've got our little grooves for rubber bands. We have a similar groove on the inside for holding a what will eventually be a little PCB or a PCB holder or a cutie pie holder on the inside. And then we get to our little nubs there intersecting. So let me instead of cutting those away, let me pull this apart. And let me see if I shift it to a rendered view. It might be a little easier to see. Oops. So you can see I have just a small little half sphere, half circle dome on the receiving side, and I have a little half ball protrusion there that snaps into. Go back. This will tumble a little faster on this computer without having that shading on, so I don't make you seasick. But you can see there, that's what I've got on 4 sides of it there, at a point where it will have to raise up just a little bit to click into place. And let me now show you from the down camera view that in action. So on this one you can see it pretty well. There's the little protrusions on one half, and there's the little receiving dots on the other. These are otherwise identical to each other. The halves are identical. And now if I go to press fit these together, you can see, I don't know if I have a previous, here's this is a few iterations ago, but you can see here, previously they would just slide together like so. Now as they go together, it doesn't matter which orientation I do, it's going to work. That is going to have to widen. You can see this one here is having to open up its little Pac-Man jaws a bit in order to click into place, and now we get a really nice fit there. And you can see I can bounce this off my little mouse pad, desk pad here, and it's not going anywhere. And in fact, I can't really open this very easily without a little bit of help from some kind of a little spudger. So this one has a bit of a gap just from my printing, some printing tolerances. But if I go like so, now we can get it lifted up enough to pop open, which is fine. It getting opened easily, these are going to be juggling balls. I don't really want that. I don't want it to be easy for these to open up. But I may make a little 3D printable tool and an intentional notch in there so that it's not so hard. But there you go. We get a satisfying click there. And here is the latest one I printed, which is in this nice translucent PLA material. Nice click, and that's together. If I, let me pop this one open. If I add our little holder that the PCB or electronics, battery, etc. are going to be in there, this kind of snaps into place there, into that groove in the middle. And that does not interfere with any of this action, since I'm putting it in the one that's not flexing, and then the one that will flex will snick into place there. It's a little harder to, if you kind of pick the wrong one to open, but there it goes, got it. So that's the satisfying click, yes. That's the satisfying click of these. One thing I was testing on these, did I? Yeah, I got it right here. I just have another one of these big 10 millimeter LEDs on a battery pack. This is a blue one. You can see, just as an idea, if I put a LED in there, we'll get a nice glow. I mean, it's obviously it's very close to that edge there, and a bit directional, especially on camera. It doesn't look quite that blown out in real life. Let me adjust the exposure here. That's more like what I see here. So it'll look nice and glowy, and I'm probably going to put 2 LEDs in there, one facing opposite sides of each other. So it should look, hopefully, something like that. And then what else is going in here? So my idea behind it, I mentioned before, is I want to have a ESP-32 S2 or S3 Cutie Pie, which is this one? Yeah, there's one. So one of these little dudes will live in there. And then I want to have an accelerometer, and I want to have a battery and a little battery BFF. That may be enough. I think that's enough. I don't think I need a NeoPixel BFF. I think I can just send out over 1 or 2 GPIO pins. If I want it brighter, maybe the BFF will be my friend, but we'll see. Best friend forever. So that's what's going in there. Ultimately, the thing I want to try out today, just because I happened to build it on a Feather for some convenience, just because I didn't have all those BFFs soldered up, is going to look more like this. So I've got a Feather ESP-32S3. I have a little LIS3DH accelerometer breakout, which runs over I2C using STEMMA QT. So this is your typical low-cost accelerometer. I think this thing is like maybe $5 for this board. It's nice and cheap. It will give us XYZ accelerometer data, but it will also give us a couple of really nice built-in conveniences like tap detection. So I think that's what I want to use, is on catch. That's when I want it to send out a little signal. The ESP32 chips can pretty much across the board use ESP-NOW. And I demonstrated this a little bit last week. I'll show you a little more today. ESP-NOW is a peer-to-peer protocol that can be one-to-one, one-to-many, many-to-many. It can be encrypted. We don't need it to be in this case. And it's ideal for sending out information, little small, like 250K, I think, packets are the biggest it can be. Is that right? I might be off by like an order of magnitude there, but small packets of data sent without needing Wi-Fi, a hub. It uses that radio. It uses, I think, that same 2.4 gigahertz frequency on the chip, but it is a protocol ESP-NOW put together that is really low power and really simple and convenient because it is not a full sort of stack that you have to deal with Wi-Fi. So it's a great little radio for sending info between boards. My idea is I'm going to have one of them, probably with a screen, maybe one of the little reverse TFT ones like that, connected to the computer or laptop as a USB MIDI device. It will be receiving ESP-NOW messages from all 3 or however many juggling balls. You can do almost an unlimited number of them because they all are just individual based on their MAC address. and then the ESP feather that's plugged into the computer will interpret those messages as MIDI, USB MIDI note messages to send, or could be CC, but I'll use probably note messages to send to the laptop or hosting synthesizer or whatever to play music notes or do other actions based on a ball landing. So that's the idea behind it, and I wanted to show you first a little demo of it in action, and then take a look at the code so far and how that's running. So before I do that, I just want to check over in our various chats here. Let's see, 250 bytes, thank you. NIC Data says 250 bytes of data encapsulated in an information element on a standard Wi-Fi management action frame. Some Nice asked, if an accelerometer is constantly rotating, how will you know which direction the force is pointing? That is such a good question, and it is why I'm going to use tap detection, because the tap detection built into the board, I think, is a bit of a fusion of the three that just knows if it has been tapped or not. I'm not trying to do orientation stuff. I may try to do free fall. I think that's a little flakier. But that, if I wanted to do two things, it would probably be free fall detection, which is probably on throw, because I don't think it knows, without a gyro and an expensive IMU, it doesn't know which direction is up or down when it's suddenly being launched. So it's kind of a, maybe it's free fall detection, maybe it's more like just another force that's somehow different from tap. But most reliably would probably just be the tap, which is almost always going to be on throw or if you tap the ball. But it's a good question. Yeah, I'm trying to keep my expectations modest, because doing like quaternion angular orientation stuff requiring 9 DOF IMU, that's way beyond what I want to try to do with these. I want to try to keep it lightweight, low power, simple. But excellent question, Some Nice, thank you. Robert Cochran says, I have about 1 million rubber bands, so I appreciate closing a sphere with them. Excellent. Yeah, you could potentially coat that in rubber bands if you wanted to make it a really nice surface to catch. And another Robert Cochran suggestion, can you add a channel area to that such that a flat screwdriver can be inserted to pry the sphere apart? I think it's a great idea. Yes, I think maybe just at one lip here, put a little flat spot in to make it easier to pop open. I like that suggestion. Thank you. So let's do, so this one I've got with a battery and the little IMU, not IMU, accelerometer. And I won't even contain it in a ball yet, but what you should see is I have it set up right now where, I'll give you a camera. Stand by. That's me. Oh, that's a bigger me. Let's go to this me. So I have it set up right now where when a tap is detected, this feather is going to send out a message that contains essentially just its name, and then whatever's on the receiving side knows what to do with that. However, I do have it also lighting up the NeoPixel on this one red. So you can see when I get a tap that NeoPixel is lighting up red. Now, timing is going to matter. This is not going to be instantaneous, but in my code, I do have the very first thing it does is send the message. Second thing it does is light the NeoPixel. Just so you'll see a little slight delay there that I think is even a little bigger than the delay of the message send, but it's probably close. But I'm aware this will have its limitations. So that's me tapping it. You can see here if I drop it, you might have seen the little red LED bop. So that's me catching. Now if I plug in this other feather, this is running similar but different ESP-NOW code in CircuitPython, which is just waiting to receive messages. And I'm sorry, I didn't bring the other two, which I showed last week, I think, with just them sending out their own little beacon colors. But you'll see, oh, maybe you'll see. Oh, maybe I told this to stop doing the LED thing. Well, let me go to a REPL and see what's actually happening. So close this. Open up the code on that feather. Did I accidentally save that code onto? Oh no, I have. Hold on, let me unplug this. I have still got that QT plugged in. The dangers of having multiple CircuitPy drives on one machine. All right, let's see. Did this one show up or not? Let me replug this in. That's better. I don't know what was up with that other one. Is that other one not plugged in? Okay. Hey, there we go. Okay. I'll get to the code in a second, actually. Let's continue looking at a little demo of it. I go here and here. Okay, so you can see this one is plugged into nothing. This one's really, the important things on this one are, the receiving one are having power and having USB MIDI out to the computer, so you'll hear a little synth noise happen when this gets tapped. Then you'll also notice, so this is wireless, ESP to ESP using ESP-NOW. When this one sends its little red, hey, I'm the red, this one is double flashing that color. So when I have 3 balls set up, you'll see red, green, blue, so you know which one has just been tapped. That's just mostly during development. That's interesting. So now with that set up, and hopefully you can hear that little synth noise as well, but you'll see the red blink on that one. Since it's all loose, it's easy to just tap it by accidentally. So throw it. Okay. That's right. Every time I catch that, we get that. So let me switch to this full view here, and let's encapsulate this inside of that ball there. I'll get rid of this. I don't need this little ring yet on this one. Hopefully we don't short anything out, because this is just loose in here. Ooh, Some had a really cool idea. Some long exposure light painting would be really cool with these. So you'll see there's a little glow of just the power LED on the feather there, or on the accelerometer. So you see sometimes, because these are loose in there, we'll get a little spurious tap because as I'm throwing it, the accelerometer's bouncing off the walls there. Let's put a little piece of foam in there actually. So let me go back to the down shot here. And I happen to have 3 hefty bags of this kind of foam that someone was donating after building some props or costumes. So I have a lot of it. Sort of pick and place foam, or what do they call that? Pick and pluck and cut, for like a pelican case. All right, so I'm gonna squish some of that foam in there, like so, and there. Okay, so now I'm less likely, I think, to get it just from the throw, just from the catch. Let's go back to a full camera view. Do I dare? Let me try juggling. Here, let me go. I'm not a fantastic juggler, but keep talking about juggling. You got to do some juggling at some point, right? So I'm going to grab some rubber juggling balls for the other two. Here we go. So it works pretty well. I hope you could still hear that. It's kind of probably faint in the background. But yeah, that was actually 100% accurate. That sounded like someone was playing Pong, says John Nodge. That was pretty accurate, only on the catches, which I'm very excited about. So that's the idea. For the final, I probably won't, in the Learn Guide, I'll say you could maybe use foam, but since that's not something everyone's going to have, I'll be relying more on a attachment of the board to the QT Py, etc., to some little ring that's being encapsulated inside of the ball. So, bing. In case you're interested, let me show you what's actually making those noises. I've got, let me go to this view. Get this out of the way. I've got a little VC rack session here, and it is using as a MIDI input, so this is a little modular synthesizer simulator, as a input, the Feather ESP32 S3, no PS RAM, CircuitPython USB MIDI ports 0. That's this one here that's plugged in. So that's acting as the USB MIDI device. And so when I catch this, you'll see, oh, there we got a false. You'll see the gate and volt per octave are being activated. By the way, I also have a little bit of a timer so that we don't get a lot of like double hits and things like that. So if it is a quick enough throw and it bounces on the throw up, we're not going to hear it on the catch. So that's some stuff that could be tuned as well. But that's all it's doing. So what that code looks like, let's hop over here. Oh, thank you. Taba says, cool, JP. John Nudge says, nice juggling. Oh, thanks. I'm trying to learn more patterns and things. But I think these will look really cool at night. Idea is not only to do this as a MIDI output, but also could use the accelerometer tap detection to do light-based stuff. So you could do some cool lighting pattern things. So code for the, I'm going to take this out of the ball now so we can see. I can plug that into USB. Sorry. Bing, 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 bing. All right, so I'm going to unplug that. We won't hear anything now. So let me plug in the ball, the sender. And let's open the, open the code that's on there. So that'll show up here. Only one plugged in, good. So you can see main thing here is this ESP-NOW. I am grabbing my list3dh over I2C stemma QT port, setting that up. Threshold, I have that at the highest threshold, so that's the most sensitive. Sorry, the least sensitive, so I don't get little spurious hits. And I have this set up so that I can just say ball A, B, or C. Could go up to D, E, F, G, H if I were ever to get to 7-ball, whatever craziness. I will not. And those have a color associated with them as well as a MIDI note right now. The Wi-Fi radio trick here that I talked about last week that Todd showed me allows you to set the channel to channel 6, which is what ESP-NOW uses, I believe. Again, I'm going to learn a lot more about just the basics of ESP-NOW and do a little guide on that in CircuitPython. so that I understand it better, but this is just how, based on some of those examples that Todd put together, how I've extended it. We get our MAC address, we set some blinking colors, we have a little tap detection routine here. This is the send, so the message that gets sent includes the device ID, the trigger type, the data, current time. The accelerometer setup. Last tap time is used to avoid it's like a debouncing. And then we can set right here, this is this longer time for a debounce. So if I want to make sure that if I accidentally tap it on the way up, that I do catch it on the way down and it's a really short throw, then maybe I lower this and suffer more for double bounces. This is just to slow things down before, settle things down before we start the main loop. And then we're checking, using time monotonic to check against how long some of those thresholds are for timing. And yeah, when we do have a trigger, we send the message. So that's how the sender works. And then on the receiver side, it doesn't look super different, except it's waiting for messages rather than sending them. But it has the addition of USB MIDI. So if you look here, same sort of stuff, setting up ESP-NOW, but we're also importing Adafruit MIDI, USB MIDI, note on, note off, control change. I may switch these to, Adafruit MIDI is going to be slower than if we just use sort of the raw MIDI. So I may switch to that just to see if we can remove any latency. It may be that the latency is all just about the little message being sent, but I'll experiment with that. And you can see here when we get a message, we grab that device's color, and that's what we double blink as right here. And trying to find my, yeah, so here's where the packet gets decoded, where we find out the MIDI number, the note number that we're playing, and the color. And send MIDI note right here is going to grab that note out of that message and then run this function up here, which just sends that out over channel 1 with a velocity of 100, a note on or a note off. One thing I'll probably add to this is a MIDI panic at the beginning when this gets reset. So just in case something happens and a ball sends a note on message and this doesn't deploy the note off message, which actually it's not dependent on the ball, but if the receiver sends but doesn't send the note off, then you get a note that's held. So it's good to have, I like to have a hit the reset, and the first thing it does is run MIDI panic, which you've seen me do before, like in the knob, little knobby sequencer last time. So that's the basics. That's how it's going right now. Let me know if you have any suggestions, ideas about this in the comments. I'm also, I've been chatting a little bit with a professional juggler who has worked with some commercial versions of these before, which just aren't made. I don't think anyone's manufacturing this type of thing. So I'm going to get suggestions from them as well for things that might be useful for being able to create performances that have this sort of light, sound, action, movement all come together. So that is it. That's what I've got going on. And I think we'll wrap it up. I will remind you, if you want to go get some stuff and get a discount on it, maybe you want to get some cutie pies, I would recommend, as was pointed out by Robert Cochran, why didn't I add a small LiPo battery to my order for cutie pie stuff? I should have thought of that. Yeah, so this coupon code will get you 10% off. If you head over to the store, I'll just give you a preview of some of the stuff I think will be in this project. Will be the Cutie Pie, not PewDiePie, Cutie Pie ESP32S3. And I don't know if it's going to matter. I don't think it'll matter which of these two. I think this first one here, they're the same price. The one with 8 megs of flash but no PS RAM happens to be slightly easier to update the bootloader on right now. That I'm sure that'll change. But if you're trying to go up to, I'm using CircuitPython 10 beta on these. There happens to be one fewer step on that one as far as flashing the bootloader. So either of these I think will be fine. The LIS 3DH is the accelerometer I'm using. It's this little $4.95, but it could be that minus 10%. I won't do that math. And then we'll need a battery BFF add-on, which will stick to the bottom of the Cutie Pie and give us a way to plug in the LiPo. You need a small LiPo, and then we can charge. The battery BFF is also a charger, so we don't need a separate charger. You won't need to unplug the battery. But again, my idea is I didn't want to deal with inductive charging. I didn't want to seal this all up in a ball and have like a USB port and a button. I just wanted to be able to open it up. So those are the main things that'll be in there, and then possibly NeoPixel BFF. I'm not sure. Possibly that. Might not need it. Less is more, so hopefully I can avoid using one more thing. And then on the receiver end, I'll probably do Feather ESP32 S3 reverse TFT. S2 would work just as well. In fact, what do I have plugged in right now? This is the S3. S2, I think it'd be fine as well. If you can get any of these with the FL antenna, it might be interesting to see if that gives you more range. I tested it last week and just walked to the other side of the shop here and got signals just fine. I think ESP-NOW is definitely, I hear the word 10 feet thrown around a lot. It's a nice range for it and it makes sense, but depending if you have like a laptop backstage with an antenna, maybe that's necessary. I can't confirm that the ESP-NOW cares about that antenna. I assume it does. So that'll probably be worth playing around with if the range just seems a little short. Other than that, those are just some suggestions, but yeah, use this coupon code to pick up some neato stuff in the Adafruit shop and save yourself some money. Okay, I think that we will call it there. Thank you everyone so much for stopping by. Thanks for jumping into the chats. Make sure I'm not missing any other thoughts there. John Nodge says, and imagine having a way to maintain internal balance might be important. Yeah, you know, it could even, I think just sort of centering the blob of stuff in this is enough. It doesn't seem to make it very difficult to juggle. The other thing I'll check, I think Lamore asked me about this yesterday, is the weight. Right now, these shells weigh about half of what my regular juggling balls do, and that's because these I'm using are a type called a Russian ball, which has something inside. These have a silicon oil, but sand is pretty common, about maybe a third or a quarter in, and that just gives them a deader drop. That's what I happen to be using. So the weight, I can probably get pretty close between them. 3 of them that all weigh the same as each other and are within spitting distance of that, perfect. Should be just fine. Good question from Fabioloso, what's your name? Let me bring you up. Fabulous. What would you do to make them impact resistant? What material did you choose for the shell, especially to protect the electronics and LiPo from shocks? Yeah, so I think the PETG would be great. I'm using PLA right now, and I may just stick with that, but PETG is going to be a stronger material. By mounting it maybe with some rubberized material or printing that in like, what do we call Ninja Flex these days? TPU. TPU would give you like a rubbery shock absorption possibly. You could also, you know, suspend it off of rubber bands inside of there so it's really shock resistant. I think the foam is going to go a long way to protecting them from shock. So you could do TPU. I have very little experience printing in TPU. I think you could do TPU ball, especially I've seen people do like little hexagonal honeycomb shapes that are very strong and flexy. So those are some options there. This could also be mostly all inserted inside of another ball if you want, but I'm going to use these little printed ones. Okay, good questions, good thoughts. Thank you so much. I'm going to get out of here. So yeah, have yourself a great weekend. I believe Foamy Guy will be here tomorrow to do a deep dive, so come check that out. Check the blog and the Discord for more info to make sure that I'm not just making that up, but I think that's the case. Yeah, and have a good weekend. I am John Park. This is my workshop. This has been John Park's workshop for Adafruit Industries. I will see you next time. Time to go juggle.